Okay, so now, so think of say xn as an IID sample from the normal distribution with say mean mu and variance sigma square. By IID meaning independent and identically distributed. So this is a random sample. x1, x2, x3 are all randomly collected data. Each of them come from the same probability distribution with mean mu and variance sigma square. Is this clear? Okay. Now think of what would be the distribution of x1 minus mu upon sigma. What is the distribution of x1? What is the mean of x1? Mu. What is the variance of x1? Sigma square. So x1 minus mu upon sigma is a normally distributed random variable minus its mean divided by the standard deviation. So what distribution does it follow? Standard normal. So this will form, this I will call Z1, which is standard normal. Think of the square of this. This is a square of a standard normal, right? So think of x2 minus mu by sigma square. Let us call this z square, z2 square. This is also a standard normal, right? Think of x3 minus mu square. This is also standard normal square. Now think of adding z1 square plus z2 square plus z3 square. So z1 square plus z2 square plus z3 square is a sum of 3 independent standard normal squares. Is a sum of 3 independent standard normal squares. But that's also a random variable because the value that x1 takes is the outcome of a chance experiment. The value that x2 takes is the outcome of a chance experiment. You know, because any element of the sample can be chosen as, any element of the population can be chosen as x1, x2, x3. So the value that it takes is a random variable. So z1 square plus z2 square plus z3 square must also be a random variable. In general, z1 square plus z2 square plus z3 square up to zn square must also be a random variable. The probability distribution followed by this random variable is called the chi-square distribution with n degrees of freedom. Why n degrees of freedom? Because there are n independent sources of variability in that data. Because x1, x2, xn are all independent random variables. Right? Yeah. Okay? And therefore, the sum of the standard normal square, if you add them, gives you the distribution called the chi-square distribution with n degrees of freedom. The chi-square distribution with n degrees of freedom. Right? This is a very useful distribution. Why is it a useful distribution? Because of the following theorem. Okay? Make sure this is a very important theorem and we'll be using this theorem again and again. Right? In the future, at least in this course. So make sure that you understand the derivation. It's not difficult at all. It's quite simple really. The theorem says, let x1, x2, xn be an IID sample from the normal distribution with mu variance sigma square. Right? Think of S square n minus 1, which is the sample variance. Which is the sample variance. S square you calculate from sample. You now know why it's n minus 1. The denominator is n minus 1. We have talked about the degrees of freedom idea in the foundation course. Right? Okay. So the theorem now says that S square upon sigma square into n minus 1 will follow the chi-square distribution with n minus 1 degrees of freedom. Chi-square distribution with n minus 1 degrees of freedom. Is this clear? Okay. Now this theorem, actually there are two ways of proving it. One is a very intuitive way of proving it. Okay. What do you want to do? You want to think of the distribution of s square upon sigma square into n minus 1. Okay. Can I wipe this off now? Yeah. So think of this is nothing but s square is this. This is s square into n minus 1. Right? This n minus 1 will go with this n minus 1. So this quantity is really which is what? Right? I goes from 1 to n like this. Now you see, if we are talking about the deviations of x around its mean, even if you have n observations, how many such independent deviations do we have? N minus 1, right? Therefore this must be a sum of n minus 1 independent standard normal squares, because we are talking about summation xi minus x bar upon sigma whole square, right? As we saw in the foundation course, if there are 10 data points and the mean of that data point is x bar, then only n minus 1 of those data points can vary independently. So if you have n data points and if x bar is the mean of those data points, then there will be only n minus 1 independent xi minus x bars upon, right? And therefore the degrees of freedom here will be n minus 1. The degrees of freedom here will be n minus 1. Sure? If you want to see it more formally, I can do it more formally. More formally, the way to do it more formally is also useful, so let's do it. See, think of s square into n minus 1. What will be s square into n minus 1? Summation xi minus x bar square upon n minus 1 into n minus 1. Right? This will be summation xi minus x bar square. Right? This will be this is okay? I can add and subtract a mu. Everything remains the same, no? Now, I can think of this as A, I can think of this as B, and I can think of this formula which nobody ever forgets, A plus B whole square, which is what? A square plus B square plus 2AB. So this will be equal to summation xi minus mu square, right, plus n mu minus x bar square. Why n? Because this is a constant, na? Mu is a constant, x bar is a constant. If you sum a constant n times, what do you get? N into the constant. Plus 2, okay, mu minus x bar, yeah, because 2ab, b is a constant. Sum over a, this part, the constant part will come out of the summation. This can be written as summation xi How did I write this? Interchange the sign. Instead of mu minus x bar, I wrote x bar minus mu, so this became minus. Now, concentrate on this. Concentrate on this. Okay. Summation xi minus mu, right, is equal to summation xi minus n mu. Okay? Sure? So if I divided this whole thing upon n, I would get minus mu. Right? Which is what? X bar minus mu. Right? How did I get x bar minus mu? By dividing this whole quantity by n. So this quantity then can be written as, this whole quantity can be written as, from which it follows that summation xi minus mu is n x bar minus mu. Right? Is n x bar minus mu. Is this clear? Right? N x bar minus mu. Sure? Now if I can substitute this, for example, here, then this becomes summation minus 2, here x bar minus mu will come, so this will become minus 2n x bar minus mu square. Right?